In this video, we're going to be taking a look at two problems where we solve for a couple values to see if these objects slip. So in both cases, we have a solid cylinder or disc. And for the first one, we have 100 newtons pulling it towards the right. And we're seeing if it slips if there is a coefficient of static friction of 0.7. So we have two horizontal forces. We have 100 newtons, which we'll call the applied force. And then we also have the force of static friction opposing the slip. And then in the vertical direction, we have the force of gravity and also the normal force as well. And these two we know are going to be equal and opposite of one another because there is no vertical acceleration or motion. Now, for the force of static friction, that's the thing that sort of sets the bar if the object is going to slip or not. Because if there's not enough static friction to keep up with this FA, then it's going to start to slide and turn into kinetic friction. So we want to take this amount of static friction to see what we get for the maximum acceleration. And then we're going to use that maximum acceleration to see what maximum force the disc could withstand and then compare that to the 100 newtons at the very end. So we're going to have to take a look at the amount of torque applied to this case. So torque equals I alpha, the moment of inertia, times the angular acceleration. And for the torque, it is the force times the lever arm. The force being the force of friction, static friction, and the lever arm being the radius of our disc. For the I, if it's a solid disc, we can go ahead and change that to 1/2 r squared. And then we're going to do a substitution for the alpha. The alpha is equivalent to the linear acceleration divided by the radius. So we're going to have an A over R over here. Now we're going to have a few things cancel out. This R is going to cancel one of these R's, and then this R is going to cancel this one on both sides. So it simplifies quite a bit, and the force of static friction is equal to 1/2 m times A. So if we want to solve for that acceleration, we could multiply both sides by 2, and then we would get 2 times the force of static friction, and then divide both sides by m as well. And that's going to give us our maximum linear acceleration. So let's go ahead and solve that. Now that is the maximum acceleration that can be produced under these particular conditions. Now, what we can do now is find the maximum force that this disk can withstand based on this maximum acceleration. So we're going to use Newton's second law, the sum of the forces equals m times A, and it would be some kind of maximum force pulling it along minus the force of friction counteracting it equals mass times acceleration. And then that acceleration would be this one right over here that we're eventually going to plug in. Now, for the force of friction, a little bit earlier, we found out that the force of friction, although I canceled some of it here, is the force of friction was 1/2 m times A. So we're going to go ahead and do a little substitution and call this 1/2 ma. Now, if you have half an MA over here and then one full MA over here, then if I add this to both sides, then the maximum force is going to equal 3/2 mass times acceleration. And I'm going to go ahead and just put in the mass and acceleration. The mass of my disk is 4 kilograms. That was given to me right over here. And then the acceleration is the 13.72 that we just solved for a little bit ago. That comes out to 82.32 newtons. Now, because that is the maximum that it can withstand, and it's being pulled with 100 newtons of force, that means the answer is yes. It will slip under these conditions because it can only withstand this maximum force of 82.32, and then obviously 100 newtons exceeds that number. Now, for our second problem, it has a lot of very similar concepts, but it's going to be a little bit different because it's an object that's rolling down an incline. So we're going to take a couple ideas from this problem and save them on the side, and then we're going to add some new ideas to the second problem to solve for if it slips or not. All right, now here are the things that we're going to save for our second problem because the ideas are very similar, so I'm not going to rework them out. We are still going to be saving this over here because the amount of static friction, again, is going to determine how much force it can withstand. So let's go ahead and pull this idea off to the side. The maximum linear acceleration is 2 times the force of friction divided by the mass. And then the second thing that we're going to save is this part over here. So the maximum force equals 3/2 m times a. Now I want to make a quick mention of some of the work I did earlier that I want to make sure that people are clear with. Is I did 2 times the force of friction divided by the mass, so 2 times, and then this is the force of friction over here. And I used mg 4 times 9.8 because I know that's equivalent to the normal force. And then for this formula, the friction formula, normal force times mu is my force of friction. That's why I had 4 times 9.8 times 0.7. So if you didn't realize where I got those three numbers from, that's where I got them from. All right, now for our second problem, like I said, I pulled these two ideas off to the side so that I could erase some of this work and then replace it with some of the conditions from our second problem. All right, now for our second problem, we have the force of gravity. We have the normal force. And then again, we have the force of static friction as well. So all of the forces are basically the same, except we don't have this pulling force of Fa, but we do have some components that are going to act like that. So we have a perpendicular and parallel component. And this parallel component is the equivalent of this 100 newtons for this particular problem because this portion of gravity is tugging this cylinder down the ramp, and we're going to see if that causes it to slip or not. So we're going to translate this 30 degrees of the incline over here, and then we're going to solve for both portions of that triangle first. All right, so let's go back to these green formulas over here. So I found both components of my FG triangle. And again, we know that this downward component is equal and opposite of the normal force because those are the only two perpendicular forces. So this is 16.97 newtons down. This one has to be 16.97 newtons upward. So with that in mind, if we're going to find our A max again, our A max is going to be 2 times the normal force times the mu sub s, which for this one is 0.4, divided by our mass. Our new mass is 2 kilograms for this one. So it looks like the 2's are going to drop out. So it's basically 16.97 times 0.4. So our max acceleration is going to come out to about 6.979, meters per second squared. Now we're going to go ahead and plug that into our F max formula again. And then for our F max, that's going to be 3/2 mass of 2 kilograms times our linear acceleration of 6.79, and then multiply those three, and it comes out to 20.37 newtons. So for this one, this 9.8 newtons is the force that is pulling it parallel down the ramp. So like I said, that's the equivalent of this one over here. So comparing this 9.8 to this 20.37, if it's being pulled with 9.8 and it could withstand 20.37 newtons, then the answer is no, it won't slip, because obviously the amount of force actually being applied by gravity is going to be a lot less than the maximum it can withstand. So this second one does not slip. So those two problems pretty similar. The second one has a little bit more work because you have to break out some more components to find the normal force and the force of gravity parallel to the ramp. But I hope that was helpful to you. Thank you very much for watching and listening.